Okay, welcome to you all to the second online edition of the Organic Innovation Days. I'm Bram Moeskops, Senior Scientific Coordinator of TP Organics. The Organic Innovation Days are the annual event of TP Organics, and their goal is to bring the latest research results in organic farming to the wider public. This year, we work together with two Horizon 2020 projects, RELACS and Organic Plus. These two projects have investigated several alternatives and approaches to some of the contentious inputs that are still used in organic farming. This morning, we will focus on plant protection and plant nutrients. In the afternoon, we will focus on animal production. Tomorrow, we will then discuss the impact, the socioeconomic consequences of these research results for society, and discuss with policymakers how these results can be taken forward and how they can be implemented. But for today, we'll first focus on the scientific results themselves. I wish you all a very interesting and fruitful exchange and discussions. And before we really start with the conference, I would like to give the floor to two representatives of the projects. And I will start with Lucius Tamm, who is a researcher at FiBL, Switzerland, and the coordinator of RELACS. Please, Lucius.
Thank you, Bram. Good morning, everyone. By way of introduction, I have prepared just a few slides to give you an overview of RELACS is about. It's really a pleasure to be with you today and to share the insights we have gained with our sister project, Organic Plus. So I'm really looking forward to see all the results from both parties. The RELACS, the acronym stands for Replacement of Contentious Inputs in Organic Farming Systems. And what we aim at is to reduce the use of copper mineral oil, to identify the sustainable sources of plant nutrition and provide solutions to support livestock health and welfare. And it was quite important to us that we don't start from scratch, but that we rather build on results from previous research projects and to take a far advanced solutions forward if they were available. In terms of timelines, it's quite straightforward. We did some data collection from national programs. We identified the current uses and future needs of these inputs. We did R&D to develop and customize available alternatives and to develop new ones. We tested or are in the process of testing them on farm, and we are currently as we come towards the end in next spring of the project, we are in the process of doing the socioeconomic, environmental, and acceptability assessment, and we are also in the process of developing roadmaps for reduction or propose potential roadmaps for the reduction of these contentious inputs. The consortium is rather large and diverse, so to speak. We have all kinds of research partners, institutions, but also farmers associations. You can find us online, of course, but the most important aspect of each consortium is really the people behind it. And you can see here a picture of all our colleagues and friends when we started off in Leuven for almost 4 years ago. And you will meet them today and tomorrow. And I'm really looking forward also to meet all the guys, how we made progress and where we will end up at the end of the day. Thank you.
Thanks a lot, Lucius, for this introduction to RELACS. And then I can now give the floor to Ulrich Schmutz from Coventry University and the coordinator of Organic Plus. Please, Ulrich.
Yes. Hello, can you hear me?
Yes, we do hear you. It's just a short welcome note now from your side, and then we can start
we start. Yeah. So yes, thank you very much. It took a little bit of time for me to connect here. So good morning. It's also I'm Ulrich Schmutz from Coventry University. It's a bit earlier, 8 o'clock here in the UK. I also want to welcome you all to this meeting, and you will have a little talk later. I think it's very important that these two consortia and two projects work together, and we have done so over the last 3 years. Our project, Organic Plus, has an extension for 6 more months because we're doing some experiments, or quite a few experiments. So we will still be ongoing for nearly one year from now. But I think we have some really good results, and it will be very interesting. I'm looking forward to look at them and see what we have got so far, and also for tomorrow, what political and further consequences for consumers we can draw. So thank you very much, and yeah, welcome everyone.
Thanks a lot, Ulrich, for this update about Organic Plus and for your welcome words. We will start now with the first real session, and that is about copper. So we will listen from the results of RELACS and Organic Plus on alternatives they have found for copper. And the first speaker will be Annegret Schmitt from the Julius Kühn Institute. That is the Federal Research Center for Cultivated Plants in Germany. So please, Annegret.
Yes, hello, good morning, everybody. And I also would like to welcome you, and I'm glad to be here to present you the results that we gathered in the RELACS project with respect to copper replacement and reduction. And now I'm going to share with you my presentation, and I hope you can see the presentation. So
yes, all works fine.
It works fine, that's great. So I'm going to represent you, as I said, the outcomes from the work package that was dealing with copper and the copper topic. And so the need for copper replacement was already recognized in the early 1990s. And international research initiatives were also launched by the European Union in 2001. And more or less recently, so one of the last calls in the Horizon 2020 project had a specific call on organic inputs, contentious inputs in organic farming. And actually, this is the call under which the projects RELACS and Organic Plus are funded, and where copper reduction, among further topics that you're going to hear about during this meeting, have been addressed. And in RELACS, as Lucius already said, we took far advanced alternatives resulting from previous research projects, and we took them over in the project to further develop them as copper alternatives. So the approach and methodology was also just introduced by Lucius. So we went along that timeline where the data collection from national programs started and where these alternatives were coming from. And then we went and looked into the identification of the current uses and the current and future needs for copper. And this is actually where I would like to start my presentation and to show you the outcome of this survey on the use and needs for copper, which was done in 12 European countries. And it was based on an expert survey, on literature and database research, then a synoptic analysis was done, and a plausibility check. And in the next slides, I would like to present you the summary of the outcome of this survey. So it was done by different partners from the RELACS project in 12 European countries. And what we did first was to look into the authorized use of copper and the estimated annual use per crop per country. So what we did was we looked into 115 crops, annual and perennial crops, and gathered for each of the countries how much copper is authorized per year, kilogram per hectare and year. And this is the first figure. And the second figure is the actual use in the country. And so we did that for all the different crops, and finally got the total estimated copper use per year in those crops, in different crops. And here you see the summary, where olives have the largest charge of copper use, followed by grapes, almonds, nuts, and then come apple and the other crops after that. So this was the first result to see where is the major copper use really applied. And then we did another step where we linked the copper use with the crop areas, the organic farmland areas. And by doing this, we resulted in a table that you can see here, where you see the estimated copper use in tons per year in the 12 European countries, the authorized use versus the effective use estimates. And what we did was we multiplied the authorized use in the countries by the area on which, by organic farmland, in which the crops are planted. So these are the numbers that you see up here. And then we did the same. So we multiplied the estimated copper use per crop with the farmland, with the organic farmland, and added this per country. And so we resulted in a total of 6,000 tons of copper use allowed, and roughly 3,000 tons of copper that were applied. So the percentage in average that organic farmers use copper was 53%, meaning that copper is used responsibly in plant protection. And so we got the conclusions regarding the copper use and the reduction scenarios. So I highlighted some of them, that at a European scale, like we just seen, the organic farmers use approximately 53% of the estimated permitted annual dosage. And this equals 3,200 tons of copper metal per year, which is also these numbers of 6,000, 3,000 tons were quite surprising. With the current technology and without innovation, no substantial further reduction of copper use is likely in the main crops. And it is also clear that it will be extremely demanding to develop solutions for all the copper uses. And it's also obvious that such solutions, like, for example, alternative plant protection products, PPPs, will be more expensive to produce. So to provide alternatives in sufficient quantities is a major challenge for research, industry, and regulators. And with this information on the one side on the use and the needs for copper in the future, we on the other side in the project were looking into which solution can we contribute in order to fill these needs and to address these needs. And so we were taking forward, as we already said, plant protection products from former projects. We looked into the optimization of formulation, which is of course important when you apply them in practice. We did research on different aspects such as mode of action, compatibility with other plant protection products, possible side effects, etc. And then a major part, of course, was the development of strategies in the different crops for copper reduction or copper replacement, and the adaptation of the strategies on station and on farm, and to validate them. And this is exactly, this part of the project is exactly what I'm going to present you in the next slides. Of course, a summary of the work that was done in the 4 years. The plant extract, one of the plant extracts, the Larix extract came from Larix bark. So circular economy is also an important topic. And based on investigations we found already before the RELACS project, important ingredients from the Larixine extract. And you can see that different projects have been involved before RELACS, where this extract was further developed. And so that was the basis to then look into the formulations. So the evolution of a copper alternative takes a while, and formulations, as you can see here, have been developed over time in order to adjust them and to make them more suitable for practical applications. And The other plant extract is the licorice extract, Glycyrrhiza glabra, and you may know that the licorice rhizomes, the licorice root, is used for teas, for medicine, for sweets. And what we use in our project are the leaves of the licorice plant. And here also a formulation process took place where the plants are extracted. You get the extract, it is dried, grinded, and then it is prepared as a micro encapsulation in lipophilic fat capsules. And you can see here some slides where you see such capsules which attach nicely to the surface of the leaves, and they stay there at the side and then slowly release the ingredients to the surrounding. So further important aspects before we can use a product in practice, the formulation I already mentioned, are environmental safeness aspects, and these have been confirmed or have been confirmed as far as known for all of our products, and the 3 plant extracts have also been investigated already before RELACS, and so as far as we know, environmental safeness is given. Concerning the modes of actions, investigation started also before RELACS and continued in RELACS, and the compatibility of new alternatives that we use with already existing plant protection products used in practice have been investigated in RELACS. And I would like to have a closer look into these two aspects that we tackled. So concerning the modes of action, we can say that all 4 RELACS products reduce the zoospore release, and this was exemplarily tested with late blight of tomato and with a downy mildew pathogen in vitro trials. And we also found that the mycelial growth of the downy mildew of late blight are reduced. So we have direct effects on different stages of the pathogen development. And the other aspect which plays a big role once you apply your products in practice is, can you use them together with other products that are used in organic farming? And this was addressed also in the RELACS project, where we used plant protection products that are already registered for organic farming. We combined them as mixtures with our RELACS products, and we looked, are they compatible in vitro as a tank mix and also in vivo on plants. And here you can see the results example for cucumber and tomato. You see here the different plant protection products that we looked into, so insecticides, fungicides, etc. And so it's of course important that you can apply other products while you grow your crop when you use new alternatives. And you can see here in the table that the green parts show there is no incompatibility, meaning that our products, our alternatives that we investigate in RELACS did not perform lower than without mixture with these plant protection products. And there were just 2 cases where we found a reduction in the efficacy, which is of course also important to know that you have to be careful when you apply such products together in practice. And now I would like to come to the crops that we addressed in copper, which of course is also the major important part. We talked about the needs, and we selected 4 or different crop pathogen systems. So grape downy mildew, apple with apple scab, cucumber with downy mildew for greenhouse crops, tomato with late blight also as greenhouse crops. And we looked into minor use specialty crops, and here selected the oil-bearing roses. And the aim, of course, was to develop strategy for copper reduction and the trials are and were performed under different field and climate conditions in several countries distributed over Europe. Now, starting with the strategies in grape vine downy mildew, the trials with our alternatives were performed in 2018 to 2021 in 5 different European countries. And so what we did was we looked into what can be strategies to apply copper in grape. And so one thing we investigated, of course, was the standalone application of the test products or the alternation of test products using copper at bloom at a very high, when high infection pressure was there. And then, of course, looking into how do they perform compared to copper standalone treatment or the other control treatments here. And so the strategies were refined over the years. And here in 2020, you can see that copper was applied during bloom and towards the end of the season. And we had another refined strategy included where the test products were used all through the season and the copper application were reduced so that mixtures of low copper treatment with the test products was done. And again, of course, you have here the different control treatments. So copper was used at 1.5 or 1 kilogram per hectare. And this strategy was then selected for the on-farm and on-station validation this year. And to summarize to you the outcome of the trials, of the many different trials that we did, is that under low disease pressure, 3 of our alternatives were effective as a standalone strategy. Under medium to high disease pressure, however, we need to apply low copper dosages. And the strategy with low copper dosages, meaning 100 to 300 grams per hectare metal ion for each treatment, in tank mixture are recommended in the last 2 treatments, usually at the Verrastro stage, in order to protect the plants till the harvest, and in periods with high disease pressure and particularly at blooming. However, it's important to really proper estimate the disease pressure to avoid treatments that are not necessary and to further reduce the amount of copper used. And therefore, the use of decision support systems is crucial in order to predict the infection pressure and to apply as low dosages of copper, and only when they are needed. So coming from the efficacy in grape, this is the one side, but on the other side, grapes are used to make wine. And so it's important to know, are there any effects on the wine, on the vinification? And we investigated this in RELACS as well, and we found no significant effects of all test products on the alcoholic fermentation, no significant differences on the main wine parameters between the treatments. Coming to the next crop pathogen system, which is apple and apple scab, I would like to introduce first what is the current use of copper in organic apple production, because we have here a more diverse situation. We have the spring season until pre-bloom. There is early preventive sprays to avoid the apple scab. We cannot use copper during flowering because of russeting problems. And then after flowering and during summer, treatments against apple scab and storage diseases are performed with 0 to 6 kilogram copper per hectare and year are allowed. And there are various splitting and combination strategies with sulfur or lime sulfur, clay minerals, potassium bicarbonates that are in use. And we have preventive and curative, which means infection stop treatments. And this situation is now also pictured in the strategies that we developed and that we looked into in apple scab. So first of all, we have the primary season, we have the secondary season, and we have here the pre-bloom season where preventive curative treatments can be done. We have the bloom we have the post-bloom, we have the summer treatments, and we have the pre-harvest treatments. And in the different strategies that we investigated, we looked into the stand-alone treatment with our test products, or we used the test product as preventive treatment, meaning preventive at pre-bloom, bloom, post-bloom, and so on. And we used the usual curative treatments that you can find down here that are allowed and that are in use, then alternating with our test products. Then we had a strategy where the test products were used as the curative treatment, while in the preventive treatments, copper and sulfur were applied. And we had the test products combined with low copper amounts as preventive treatments. As preventive treatments. And then, of course, we had the post-bloom standalone treatment with our test products, and we have the post-bloom treatments with a test product combination with curative treatments as they are usually done in practice. And we had the post-bloom combined with low copper and the curative treatment as they are done. So you see a very diverse and diverse layout of the trials and of the strategy we investigated. And I would like to show you the summary of the results that were done. So trials were done also between 2018 and 21 in 4 different countries. And the results for the primary season SCAP control were that all the new test products show partial efficacy when used as standalone, and one of the test products showed similar efficacy as copper. And when combined with other standard fungicides, the efficacy of our test products is similar to the reference strategies. And in the secondary SCAP season and the storage diseases, 3 of our test products have the potential to replace or partially replace copper, while we are waiting for the results on storage diseases. And as conclusions, we can say that all RELACS test products show a significant disease reduction compared to the untreated control when used as standalone. However, they are not effective enough. And when combined with other standard fungicides, the efficacy of the test products is similar to the reference strategies. So our test products can be applied in combination with either sulfur or potassium bicarbonate products, or in tank mix with low copper dosages. And individual integration of the new products in specific strategies is necessary here. So the use of decision support systems is crucial for optimized timing of applications, and only when they are really needed. Coming now to the vegetables crops that we investigated, the cucumber and downy mildew, again from 2018 to 2021, trials were undertaken. And here the alternative test products were applied as standalone treatments. And I would like to give you an example of how the results looked. So you can see here, this was a trial in Spain. You see the untreated control and you see the disease severity on the leaves. Here is the copper treatment, and we showed that our test product was not significantly different to the copper treatment, but all of them were significantly different to the untreated control. And as a conclusions from our trials in cucumber downy mildew, we can say that one of the test products showed good results as stand-alone treatment. In greenhouse, with advanced techniques for management of climatic condition, treatments are not required. However, in greenhouses without such techniques, copper is usually used and treatments are necessary under conducive conditions. And looking into the tomato late blight situation, again, trials were done in the same time frame. And again, the test products were applied as standalone treatment. And here another trial where 2 of the test products were used. So the untreated development of disease in the untreated control, disease severity on the leaves can be seen here, and the 2 test products can be seen here. Both provided remarkable disease reduction, disease symptom reduction in comparison to the untreated check, and one was also comparable to the copper treatment. So also here we found that 2 of the test products that we investigated showed good results as standalone treatment, and again, they can be used in greenhouses where techniques to manage the climatic conditions are not available, and where conducive conditions are prevalent. I was showing you in one of my other slides that we looked into another crop, into minor use specialty crops, and here we selected the oil-bearing rose. And in Bulgaria, oil-bearing roses are planted and play a big role. So we also tested our alternative products as standalone treatment or also in combination with sulfur. And here we did not only look into the development of the diseases, but also into what is most important here is the yield of the rose flowers and the yield of the rose oil that was investigated in RELACS. And I would like to show you here from an example from one trial. Again, 3 years of trials were done. And I would like to show you the results from this year, where you can see in the rose-colored columns, this is the rose oil that was harvested. And the green-colored columns, you see the fresh flower weight in kilograms per hectare, rose oil in grams per hectare. Here is the control yield, here is the copper treatment, and here are the test products and the combinations that we applied. And you can see that compared to the control, all of the treatments yielded higher amounts of rose flowers and higher amounts of rose oil. And in summary, we can say that all test products showed good results in standalone treatments, and we had a significantly higher rose oil yield observed in the copper alternatives in all variants in all 3 years of the field experiments. So the overall conclusions from RELACS, and of course we had many different trials, and this is a very condensed version of the outcome that I could show you today in the 30 minutes. But the overall conclusions we can say is that control strategies, either as mixtures or as alternations or as standalone use, based on the RELACS alternatives have been explored for the different crops under investigations and many different trials in many different countries and years. What we see is that none of the alternatives covers all uses of copper, but together the 4 alternatives coming from within RELACS and the 1 alternative coming from outside of RELACS, they complementarily tackle all investigated diseases. What we found is that the application technique and the time is crucial, and therefore the strategies applied in different crops should include decision support systems whenever this is possible. And so we asked ourselves at the end of the project, what can we say about copper? And the question was, are alternatives available? And the answer was, yes, they are available. What is the potential for the reduction of copper? And this, we found, depends on the crop and on the location, but we expect 10 to 50% of reduction possible. When are the alternatives available? So what is the technical timeline, including inclusion in organic regulation? And this depends on the alternatives, as they are in different stages concerning the registration. And we expect earliest availability after 2026. And of course, a major question is, what are the major bottlenecks to bring such alternatives to the market and make them available? So here is the registration, the availability, the acceptance, and the costs. And these, of course, are aspects that will be addressed. And Lucius mentioned that we are looking into the phasing out in the roadmaps, and these parts will be addressed later on, and also in the European workshop that will take place in 2 days, where such aspects are going to be discussed. And so I would like to thank you. I would like to thank all of the RELACS partners that contributed here to the work, and I would like to thank you for your attention.
Thanks a lot, Annegret, for this wonderful and clear presentation. We have still a little bit of time left before we go to the next presentation, so I will pick up already some questions from the audience. In the meantime, I invite everybody to post their questions, because between 10:30 and 11, we will have a half an hour time slot for a detailed discussion on all the presentations on copper and mineral oil. But the first question for Annegret already, coming from Anne-Christine Leus, is whether RELACS also worked with decision support systems. Did you investigate the efficacy or the functioning of some decision support systems?
We used the decision support systems in the grape and the apple trials as basis for the application of the copper and of the alternatives, yes. So they were included in order to get the best results out of the trials. Okay,
thanks a lot for this clarification. Then we will go now to the presentation of Nikolaos Katsoulas from the University of Thessaly. He's a researcher in the Organic Plus project, and he will also present their findings of copper alternatives. Please, Nikolaos.
Thank you, Bram. Thank you also, Annegret, for this great introduction, which helped me a lot in my presentation also, because you introduced a lot of things. So I will present from my side the work that has been done from the Organic Plus project with the title Pathways to Phase Out Contentious Inputs from Organic Agriculture in Europe, and the work related to copper and to the alternatives and the decision support systems that are developed in the frame of this work. My name is Nikolaos Katsoulas, as already seen, and I'm professor at the University of Thessaly in Greece. And this work is also, I will present also the work from my colleague Miguel de Cara, a partner in Organic Plus from IFAPA in Spain. So the presentation is split in 3 parts. In the first part, I will try to present a few words about the Organic Plus project and the approach that we followed. And then I will try to present the alternatives studied and the decision support systems developed in the frame of this project. So, as in RELACS, in Organic Plus, we took the same approach at the beginning, and this approach was to start from the practitioners, from the farmers and the advisors, with interviews and work with them during the project in the evaluation of the alternatives and of the practices that are tested, and then go back to them again to present the final results of the tests that we have done. So we did a survey also in 10 countries for 14 crops, and the survey was related to the use of copper, of sulfur and mineral oils in organic farming. And also we studied the regulations in each country and tried to see which are the levels of the copper and mineral oils used in each crop. In this work, we took interviews from 1 to 3 experienced advisors per crop, because we know that each advisor is working with several growers, and in this way we can have the opinion of several growers concentrated in one advisor. That is an efficient way to collect these data. And these data have been already published in the frame of a publication that has been done in this project. So I will just present a few results of this work. So we worked with several crops, and some of them are presented here as olives, citrus, and tomato. And we know that the maximum limit is about 6 kilograms of copper per year and per hectare, and that this limit is now reduced to 4 kilograms per year and per hectare. And we see that in some cases we are at this level at 4 kilograms, for example, in Greece and in Italy in relation to copper, and that in some other cases we have higher values used, as in France and Spain, for example. Where in France, for example, we have the application of Bordeaux mixture with 2-3 applications per year, while in Greece it's depending on the climate conditions, on the grower's knowledge, and on the cultivar sensitivity, and it may be applied from 1 to 6 kilograms of copper per year and per hectare. In Italy, we have drier conditions, and this helps to reduce, in some cases, the use of copper. In citrus, we see that in Italy we have high application of copper, and sometimes it may exceed even the 8 kilogram of copper per year. And also in relation to tomato, we see that the tomato is cultivated mainly in low tech greenhouses in Greece, in Italy, in Spain, and in France, and we see the difference that are mainly depending on the period that the cultivation is done, and also on the systems that are included in each greenhouse in order to control the climate control in the greenhouse. So from this survey, in relation to the alternatives to copper, we could group the alternatives according to their mode of action in 3 main categories. Methods that act directly on the pathogen itself, methods that act that make use of plants' own capacity for the resistance, and methods that use agronomic practices to fight primary infection or secondary infections. While the questionnaire identified some solutions already available or used by growers, the frequent and abundant use of copper, and to a lesser extent sulfur and mineral oils, so that these solutions are either not widely adopted or not fully satisfactory. Many alternatives to copper are under development, but few are already available on the market, and fewer still are currently used by growers to any substantial extent. So zero copper in plant protection cannot be achieved by a simple substitution strategy. This was the result of the survey. For instance, by replacing copper by biocontrol products. It requires a more or less profound reconstruction of the crop production system, including changing of cultivars to favor resistant ones, developing prophylaxis and sanitation measures, adjusting fertilization, etc. So this requires an integrative approach, which is still, of course, under development. So following the survey that we did, then we went in the lab to test some of these alternatives in lab experiments to see the mode of action of these alternatives and to facilitate the transfer of their lab efficacy to field conditions. And we had the in vitro assessment of the performance of the alternatives, and finally field assessment of alternatives to copper substitute or alternative strategies. So we tested several crops focusing in the Mediterranean region, and we worked with eggplant and olives, tomato, citrus in the Mediterranean region, and potato mainly in Central and North Europe. So based on these experiments in the lab, then we designed the phase-out scenario, several phase-out scenarios for the different cases and the different crops. And these scenarios designed relied on either a single control means, usually host resistance, or a combination of up to 6 control means. And in addition to host resistance, such control means can include different types of biocontrol applications, sanitation, infection, scouting, and monitoring. And in relation to plant protection system redesign in these phase-out scenarios, we tried to develop some DSS, some decision support systems that Annegret mentioned that are needed for the application of the alternatives or even of copper when it's used. So we developed 2 different kinds of models for potato control potato disease, a mechanistic model applicable to pathogens with expanding lesions, and a DSS for early and late blight that was tuned into a fully operational DSS tested under different scenarios, mainly in potato in Central and North Europe. And then another DSS was designed and developed and will be presented in detail below. That was a warning system for forecasting the occurrence and incidence of botrytis in a greenhouse based on plant and future climate data. And this system is tested in Greece and in Spain under greenhouse conditions. So I will present a few more details about the alternatives tested. Mainly, this part refers to the study and the results obtained from IFAPA in Spain, working with copper alternatives in greenhouse tomato against botrytis. So the results related to citrus, for example, or olives or eggplant that were also studied will not be presented in this presentation. So in relation to the alternatives, these were selected based on the interviews with experts who advise, of course, several growers, each one. And the information comes from real growers who apply many of the alternatives with good results. So we did not develop new ones, new products, but we used those that are available in the market, but for different purposes. And we tested those that had good results, at least from their practical point of view, from the practical point of view of the advisors. So the alternatives to copper can come from different groups of solution, always thinking on therapy to be integrated with other practices. In the European Union legislation, there are at least 22 authorized alternative products, but this number is increasing. And we tested some 7 authorized ingredients with plant extracts, potassium bicarbonate, and chitosan, and some basic substances that at least there are 15 available. From those, we choose 12 alternatives that were suggested by the experts, and these include the fertilizer copper gluconic, 5%, including 5% copper, silicon, cinnamon extract, potassium bicarbonate, chitosan, lime sulfur, and some more plant stimulators. For some of them, different formulations from different manufacturers were tested. And the in vitro tests were performed with botrytis, of course, and with two types, fresh botrytis isolates collected from commercial greenhouses in Almeria with high disease impact. Two isolates with different behavior were used, one growing fast and the other sporulating very fast. The products that were tested for the minimum and maximum concentration recommended by the manufacturers, and the products tested are listed in this table. I'm not going to give more details about it. So passing to the results of these tests, we have here the gluconic copper, for example, that is tested in the maximum concentration, in the minimum concentration suggested, and these are compared with copper oxychloride that contains 50% of copper. So we have the different treatments here and the colony growth inhibition percentage here. So we see that the gluconic copper is very effective with only 5% of copper, that is 10 times less than oxychloride, and showed the high efficacy on inhibiting the growth of botrytis, and even good results from the fast sporulating isolate were obtained at minimum dose. From the other hand, well-known basic substances did not inhibit botrytis, and we see that the results in comparison to copper oxychloride were worse in some of these cases. So in this case, the efficacy that was experienced by the growers that suggested the use of these products can be related to the response of the plant after the application more than to the fungistatic effect of these products. So there are some alternatives that are used, but may be connected to the effect after the use and not exactly to the colony growth inhibition as is studied here. Two very different formulations of cinnamon extracts showed a very high efficacy in the laboratory, but not the other extracts tested. So we have two cinnamon extracts with high dose and low dose here that gave very good results in comparison to copper oxychloride. And at maximum doses, cinnamon even killed botrytis. Also, potassium bicarbonate killed botrytis at high dose. This product is EU authorized on tomato to control powdery mildew, the oidium that we know. So we had very good results in comparison to copper oxychloride in the tests that were done. So we had to think about the cost of these products that were tested and if in fact they can be used in practice because of the high cost that they have in relation to the common products that are used. So taking into consideration the efficacy in vitro, we needed to advise about the competitiveness of the alternatives versus copper, and the prices are very high for the alternatives, but for a tomato crop in during the winter period, can be affordable if the dose is the minimum that is applied. Another thing that passed from our mind is that these products were very good in efficiency, and we thought that it may be possible that the formulations contained chemical fungicides. So all the effective products tested in vitro were analyzed for the presence of 43 fungicide compounds, and it was found that none of the fungicides was found in these compounds. So this is a good result. So passing from the lab, let's say, to the field, we carried out experiments in the greenhouse using the information that was obtained, and 2 greenhouses of about 1,000 square meters each were used, greenhouse 1 and greenhouse 2, in parallel with a third greenhouse of 2,000 square meters of covering area. These are referred from now on as greenhouse 1 and experiment 1 and experiment 2. The products tested were potassium bicarbonate, 1 cinnamon extract, and copper oxychloride for benchmarking to compare all of them, to compare with them to see the efficiency. So the first year, there was a high botrytis infection in the greenhouses, and the alternatives could be tested in a good way. This was very good for the test, of course, not good for the growers during this year. So we had 5 spray applications of the 3 treatments on the same day in both greenhouses within the same week. And we had the application on weeks 48, 50 during 2019, and weeks 2, 4, and 6 on 2000. The infection sites, as well as the number of infections per plant and plant infected, were recorded. The worst site for infection was the petiole. Once pruned, this point started an infection that evolved, covering the whole stem diameter and killing the plants a few weeks later. And we can see here fruit, petiole, and dead plants in these figures. So passing to the results in the field experiments, we see that in the experiment 1, that includes greenhouses 1 and 2, stem infections were not very high. Botrytis appeared mostly on fruits and leaves. About the efficacy of the alternatives, we see that not significant differences were observed between the treatments. We see only a tendency that the cinnamon extract gave worse results than the other 2 cases tested here. In the experiment 2, however, there were significant differences, with the best results on controlling the disease given by potassium bicarbonate. And in experiment 2, there were many petiole infections which derived into plant death, as we can see here at the end of the crop, mainly in the treatment that was treated with cinnamon extracts. So there are alternatives commercially available that can substitute copper formulations in terms of efficiency and efficacy. However, the price of these alternatives makes them interesting only for high-value crops. On the other hand, our experience shows that depending on the weather of the year, there are practices that can be good enough to manage botrytis in the greenhouse without or with low applications of therapeutic products. The smart integration of these practices, that is climate control, pruning, variety selection, can limit the disease. And in taking into account this aspect, I will continue on with the DSS that is developed. Of course, we need more work, more knowledge to do, to collect, to improve the integration of these practices in the field. So, in order to apply better these products and use them when is necessary, we developed a DSS for botrytis risk assessment in greenhouse tomato. Of course, as already said, another DSS was developed for potato. So, in order to develop the DSS, we need to know the mechanism of development of botrytis. So, from my side, as an agricultural engineer, I need to know, for example, how the climate affects the development of the disease and how these can be incorporated in equations that can be used in models and then use these models to predict this process. So, as we know, in the greenhouse environment, we have always botrytis conidia present, and there is a process that we have to take into account: the germination, the penetration, and the establishment of the disease of botrytis in the plant. So we are trying to model these 3 steps here of the development of the disease and trying to model in relation to the climate conditions. So in order to have the development of the disease, we have free water in the surface of the plant, and we have free water when high humidity conditions occur in the microclimate of the plant, usually when the air relative humidity exceeds 95% of the air vapor pressure, and the air vapor pressure deficit is very low, close to 0.2 kilopascal. Also, free water on the surface of the plant tissue can be provided by condensation of air-water vapor on plant that is related to plant temperature. So we have 3 conditions that are very important: temperature, relative humidity, and leaf temperature that have to be taken into account. Also, the conidia deposited on a plant tissue covered by a layer of free water need a minimum wetness period to absorb water and then complete the normal process of their germination. So if this wetness period is not completed, or if it's interrupted before completed, the conidia do not germinate. So the need also for this wetness period depends on temperature. So we have this information available from the literature that the germination begins after incubation of 4 hours at 22 degrees of Celsius, and the rate of tissue infection increases by increasing the duration of tissue wetness at all temperatures. And a minimum of 4 hours is determined as the shortest period that conidia need to germinate. Some studies have determined the limit values of the microclimate parameters that are necessary for the completion of this stage of infection. So the development rate of botrytis cinerea depends on the air humidity values around the host tissue that have to be high, above 85%, and on the temperature that is on the air. Another parameter that we have to consider is the spore pressure, and the release of conidia after sporulation initiates the dispersal of the disease. The conidiophores, where conidia are created, need a sudden drop of air relative humidity to split the conidia of botrytis and disperse them to the greenhouse environment. So all this information is transformed to equations in order to take into account the development of the disease in relation to the climate conditions inside the greenhouse. And since we want to predict the climate conditions, and in fact, we want to predict if we are going to have infection inside the greenhouse and development of a disease, we need to predict the climate conditions inside the greenhouse. And we have models, there are available models that take into account the outside climate conditions in order to predict which will be the conditions inside the greenhouse in relation to temperature, humidity, leaf temperature. And based on this prediction, we can then use the equations related to the development of botrytis and assess the risk for development of the disease. So we take the prediction of the weather, we estimate the climate inside the greenhouse, and then we run the model to see the infection that is predicted by the model. And the model, in fact, gives us information on the conditions that we are going to have inside the greenhouse during the following week, 7 days prediction of weather inside the greenhouse. And based on these predictions, we can advise the grower if there will be a risk for the development of the disease and how much this risk will be by predicting also the disease development rate and the spore production density inside the greenhouse. So we tested these DSS and we are completing these experiments in greenhouses in Spain and in Greece. And first of all, we wanted to validate if the weather predictions that we take outside the greenhouse are good enough to run the models. And here we can see the temperature that we measure and the temperature that is estimated by the weather forecast, the air relative humidity that is not very well, let's say in this case, estimated, and also solar radiation and wind speed that are outside conditions that affect the greenhouse microclimate. And then, taking into account the model, we predicted the climate inside the greenhouse, the temperature, humidity, and leaf temperature. And based on these predictions, we run the model and we see the spore production density that we may have inside the greenhouse and the disease development rate that is shown here by these blue dots. So the decision support system can help us in controlling better, in predicting better the infection risk that we may have inside the greenhouse for a tomato crop. The model is also connected to a decision support tool that give advice on the reduction of air relative humidity, of the presence of free water on plant leaves, and also advices on tactical and strategic decisions, how to avoid the develop these conditions inside the greenhouse. A future challenge of this work is to develop a country-level disease dynamic system where, based on the models incorporated in this system, the real-time weather forecast data from different regions will be used to assess the potential disease severity and disease dynamics in different regions for different greenhouse types and control management strategies. A first manuscript in relation to the system development has been already published that includes this model as has been developed in the frame of this project. So I'm in my final slide. I would like to thank you all for this opportunity to present the work here, and of course to thank all of you following this presentation and the colleagues of Organic Plus that we have developed all this work together. Thank you very much.
Thanks a lot, Nikolaos, for this very insightful presentation. Before we go to the next speaker, I will again ask you one question from the audience, and also all the other people are very well invited to post their questions in the chat function. The question that I will ask is coming from Sabine Tsikeli about the cinnamon extract. You showed that it was a more effective or only effective in vitro, but not in the field. Do you have any knowledge why this could be, or do you have assumptions why this could be?
I'm not a phytopathologist myself. I'm an agricultural engineer, and I will try to say a few words about this. I think that it may have to do with the way that is probably applied in the greenhouse. I have not.
Okay, I see that Annegret wants to come in. If we can get her on the spotlight, then perhaps we can allow her to come in. Yes, Annegret.
Yes. So I may be able to answer the question because we've been working also with not cinnamon extract, but with cinnamic aldehyde many years ago against powdery mildew, which is quite active here. And if you have a closed system in vitro, then you have this vapor pressure of the volatile compounds in the cinnamon extract. And I suspect that when you apply it in the greenhouse, then the volatiles will disappear quite quickly in comparison to the in vitro in the Petri dishes. And I know that in our trials, then we had to use such a high concentration of the volatiles that you virtually couldn't enter the greenhouse because it was so smelly, so to say. So I think that could be an answer to the question.
Thank you.
Okay. Thanks for bringing that in. And so while we go down to the next presentation, please, everybody post your questions for the debate that we will have later today. I will now introduce Vincenzo Verrastro, who is a researcher at CIHEAM-IAMB, that's the Mediterranean Agronomic Institute of Bari, and he will present the RELACS results on replacement strategies for mineral oils. So please, Vincenzo, the floor is yours.
Good morning, everybody. I hope that you hear me and you can see my screen. Please say yes, someone.
Yes, it works well. Yes, perfect.
Well, fantastic. Thank you, Bram. My short introduction will be about mineral oils. This is the list of people that worked with us during these years. And the first one is about the paraffinic oils. While they are considering so dangerous, first of all, because they are not a renewable resource, they are affecting photosynthesis and transpiration. They can generate phytotoxicity in their treatment, and they're affecting even natural enemies. This data has been mostly confirmed during these years and started like my colleague did in the recent presentation and work package. I will go to the data collection that we did among different countries, not so much as the one in copper, but only 8, including 3 non-European countries. This is a list of the treatments and the amounts that normally we found in different countries. Some of them are used only in a greenhouse stage and not only in open field. The table is about the amount in liters and the number of treatments that change a little bit according to the countries and to the climatic condition in open field. But we can affirm that, as you may see, paraffinic mineral oils are mostly used in the southern Mediterranean countries and mainly on citrus and even in other crops, but it's not so often like in citrus. The conclusions starts from a preliminary status that sometimes in the registration process we found differences between mineral oils and paraffinic oils, mainly based on their carbon chain lengths. This was not so good even to define the amounts. Their use in non-Mediterranean countries, non-European countries, is complicated to achieve because data and registration are not so in line with European standards, and several countries we found are reducing the amounts of them, starting even from other kinds of substances and with other kinds of strategies. Hopefully, we are going to list something which is interesting for the others, even according to these new innovative strategies. And following always the pathline of our presentation, our work was based mainly on three alternatives, who are sweet orange essential oils, clitoria alternata extract, and vibration control, or vibrational better control. I start with the open field trials that was done in citrus orchard, of course organic, based on different comparison between the essential oils and the clitoria alternata extract applied at field level. Our targets were mainly two of the most important pests for this kind of crops, who are citrus mealybug and orange spiny whitefly, or Aleurocanthrus spiniferus, which probably is not so well known, but is a new imported pest in Mediterranean countries coming from abroad, as usual, that we tried to fight using these alternatives. We did in a real farm placed in the southern part of Puglia, and the final conclusion of these trials were that orange essential oils are effective against mealybugs in stages of nymphs and females, that clitoria works well on the Aleurocanthrus spinifera in all the inserts of nymphs considered, and there is a repellent effect of orange essential oil and pyrethrin on adults of both spiniferus and an attractive effect of clitoria alternata. We publish a work about that, but as I even seen in the chat, there was another important topic to consider, that was the efficacy or not efficacy, or the killing aspects of these alternatives on the non-targeted insects. And so we selected a couple of beneficials who are well known as parasitoids, Leptomastix dactylopi, and predators Cryptolemus montriuseri. We did a trial work at lab scale, especially to see if there was the possibility to have effects of residual on adults. So we put the treated crop in one cage with Cryptolemus, and we transferred after 24 hours in order to evaluate this efficacy on the daily predation rate of adults, on the daily predation rate of larvae, and the survival of the adults. We did more or less the same, but of course there is no predation but parasitoids on the Leptomastix, so we did the same thing at lab level, evaluating the survival of the parasitoids after the treatment with the two alternatives, and the final conclusion can be more or less summarized in this way. The mineral oil confirmed that there is a negative effect on natural entities once we treat them as well as we are doing now in organic agriculture, not using alternatives, on female parasitoids as well. Orange essential oil and clitoria alternata extract applied separately are a good strategy to replace the paraffinic oils, not affecting the survival rate of the parasitoids and predators at open field. But during these treatments, we came even to a new situation, or a better or a different aspects of the treatment with these two products, single standing or mixed together, that there was a little and sublethal effects on some pests, and not only the parasitoids, that needs further investigations. And this is ongoing, is always in RELACS. We are using a different aspect, different tool, the name is APG, in which we are using and studying on the two main pests, Planococcus citrus and Aleurocanthrus spiniferus, the effects of the feeding behavior of these two pests once they found the crop was treated with these alternatives. We are also using, in terms of possible other products, the pyrethrin. What is the take-home message that comes from the open field trials? The first one is that against Planococcus citri, the combination of clitoria alternata extract and sweet orange essential oil is the most effective against the adult females. Against Aleurocanthrus spiniferus, the combination, the sweet orange essential oil has an effect of landing an oviposition, And then using Clitoria alternatia, the result fits on the feeding behavior. So we need to have a chemical stimuli, probably can be used to manipulate the pest behavior. And this is one of the most interesting findings of all these research activities carried out. And a new study is on the way, and the data will be ready for the beginning of 2022, and probably there will be a publication immediately after. As a second stage, we moved to a greenhouse trial that we did not exactly here in the CIHEAM-Bari, but in collaboration with Edmund Mack Foundation in another part of Italy. The evaluation of the alternatives was against whiteflies, and there was even the use of a physical device in the greenhouses and the optimization of all the three systems that I told you in the previous slide. And so orange essential oil, Clitoria alternatia, and vibrational. All these trials were done on tomato and zucchini, evaluating the different inserts of the greenhouse whiteflies, such as adult, nymphs, and eggs. This is a very complicated slide because I will need several minutes to explain what is vibrational schemes. Anyway, it's a recording of the vibration that any kind of pest produce using sophisticated equipment such as laser Doppler vibrameter, moving that in an anechoic chamber, using a macro lens, and placing all these issues on an anti-vibration table. The dimension and the size of the pest is fundamental in order to record it. Vibrations are a stimulus that pests normally use to make two different things. One is about mating, one is about feeding behavior. So this is a slide that I only invite you to see, because it will take too much time to explain. This, as you may see, there are recording stages of all the aspects, such the call, the alternative duet in the whiteflies, the courtship using the alternation, the overlapped duet, and finally the mating. It's a movie that someone can see, but it's important for us to know in the behavior of pests, but it's crucial to develop eco-friendly control strategies. There is, of course, an emitter of this vibration that should be placed in the greenhouse. This is one of the tremos prepared by the CBC group that we placed in a real greenhouse in the Mack Foundation. As you may see, there is a new device prepared for these crops. There are plates in which under the plates, as you may see, there is a vibrator or an emitter of these tremors of these vibrations. Then this is the picture of what we did at greenhouse, and each one of these cage has a plate down. This is more or less a scheme in which we had 1 cubic meter, in which there was a board places on 5 emitters on it to 5 vibrating plates. 30 crops were placed within each kind of cubic meters. The intensity of the vibration was put at 200 Hertz. I will go in details later during the Q&A questions if you want more details about it. There was the inoculation, of course, of the whiteflies, and there was a spray of the two alternative products, so Clitoria and orange oil, plus the combination of the vibration. We did one treatment more or less each 1 week, 2 weeks. Of distance. What are the take-home messages that I would like to do about this? Clitoria alternatia and orange oil, as we know, as we did, like colleagues did in the previous work package, are physically and chemical compatible each other, so they can be used even together in treatments at greenhouse level. The mixture should or must be applied once we see the results of the infestation. So the early presence of adults is quite important in order to have efficacy on this treatment. The application can be repeated more or less every week or every 10 days, but it's always according to the pest pressure of whiteflies that we could have. The combined use of the two alternatives, and so Clitoria alternata and orange oil, have high efficacy in controlling this population in the greenhouse, but they are improving because the trials are still ongoing with significant results if they are coupled with the vibrations that I showed you before. We have some traps at the moment. I saw yesterday the picture of them in the greenhouse, and the number of catch that you have in these traps where there are even the vibration in the greenhouse is quite less than the one that you find in another place of the greenhouse in which we don't have the vibrations and only the treatments with the two alternatives. Even in this case, things are going to be published in 2022, according even to the experimental trials that we are doing. At last, but not last, this is a picture of my experimental field. This is a young citrus orchard in which we transplanted more or less 4 years ago, in which we are, as you may see, planted several conditions in order to create the first probably citrus orchard vibrations with vibration inside. How is composed? There is a solar panel at the beginning. There are cables that reach the crops. Near each crops there is a tremor, the one that I showed you before. And since 6 months, we are monitoring the effects of the couple at open field level of clitoria, of orange oil, and of vibrations, and making some treatments when it is necessary, and monitoring the level of infestations of them together. Things are going extremely well, I can say. There was some technical problems at the setting up because this is a really new and innovative trial. But the efficacy of the treatments are going steady well, considering even that we are still in December, we have another couple of months to make the observations. What are the final take-home message that we can give about the use of alternatives and specific about the paraffinic oil substitution? The alternatives are available. The full answer is yes, but probably there must be a mixture between the alternatives products and the vibration as well, because all three of them should be considered feasible, and they are showing a good efficacy in different places, at different levels, and in different moments. They are perfectly in line even with the EU policy and strategies in which the reduction of the chemical inputs and the use of alternatives are suggested from European regulation, and they are environmentally safe, even because other trials, other comments on the use of vibration, especially, are not arrived since today, even if it's still a preliminary, let's say, strategy, but works even well on other kind of insects or problems who are not exactly linked to the project, such as Allomorphalis and as well. The potential for the reduction of the use of the mineral oils or the paraffinic oils is, in according to our thoughts, between 50 and 100%. What does it mean exactly? That according for citrus and vegetables, this can probably reach the higher percentage that I'm showing. In other kind of crops, we need to test. For instance, the other crop on which we found the use of paraffinic oils are olive trees, but still there is no trials on this using the combination of the three products, so we need further investigation. Are they technically available? The answer is not exactly one. About the use of orange oil, they are already marketed, so it's PPP already on the market. The use is free according to the willings of the farmers. For the clitoria, the process of registration is going to finish in 2023. So it will be available not very soon, but I hope in a short, limited time. About vibrations, they are available, but it's not possible to use vibration without any kind of guiding structure of people that teach or explain how they must be used, what is the setup, and different things. So that we need an action plan to do this without any kind of doubts on it. What are the major bottlenecks that we are able to find in this? There is some cost of farmers because vibration are not easy to be installed in the field. It's not complicated, but you need a careful installation in order to, and check in order to see if they works. For instance, 24 hours a day, so it depends on the pest you are looking for. So we need preliminary survey of what we are going to do once we are going to install the vibration. There are further research needed, unfortunately, for the devices, because each device should be set up for the best considered, and there is a support for the introduction in this kind of establishment. But I can affirm that in 2 years, some things are going to change, even because, for instance, these years in another part of Italy, we are going to introduce in another research project a new trap for Allomorphalis based even on vibration. So it's a preliminary scheme, but I think the future is not so far. As my colleagues did before, I would like to thank the opportunity to study and investigate this kind of new research with all the partners of the RELACS project that allowed me and my colleagues to work in this kind of specific and new and stimulant exercise of research. And I'm free, of course, to have questions about it. Thanks.
Thanks a lot, Vincenzo, for this presentation and the exciting new technology of using vibrations to combat pests. One follow-up question is coming from Ulrich, who asks what would be the energy needed to run this vibration device in an orchard of 1 hectare or in a greenhouse?
We are trying now, and we have a small solar panel with a battery. The size exactly I can give further details, but what we installed is for a 1/4 hectare. We have 9 rows of crops. We have 4 installations, so 4 rows are installed with the devices. I can say that the battery is a small one, the solar panel is a small one, as the tremors. But in real, we gave also an estimation of the cost in order to finish the installation of 1 hectare. The cost today is around 2,000 euros.
This is the cost for installation.
Installation, setup, whatever. I mean, in order to lay the station work, let's say. We don't know if, according to the dimensions or number of installation, this size can be reduced among the years. We hope so. But the real situation is that more or less the price is on this. Of course, we don't need any kind of electricity because everything is, let's say, driven from the solar panel. So we don't have any kind of net connection or whatever. We can even use it because I heard in the previous presentation connection of this kind of tool with the decision support system. We are trying to do it in my institute even.
Okay, good. Thanks a lot for these additional explanations. Then to continue the discussion, I would first like to go back to the copper presentations. Some people remarked or had the impression that the estimates of copper use were different between the RELACS project and the Organic Plus project. The reason is probably the difference of methodologies used. But I was wondering if perhaps Lucius would like to come in and comment on these differences that were observed.
Yes, thank you. First of all, I don't think the differences are really big. We are talking about similar magnitudes, and the difference of 10 or 20% or so is not really significant. We should also keep in mind that both teams have attempted have walked unknown lands, so to speak, because the statistics are really poor. And it's incredibly difficult to find at this stage to find plant protection products statistics data. It will come up in the future, but as of now, it's real unknown. And by the way, this, in my view, is the real scandal. We simply don't know which PPPs are used where in what quantities. So insofar, I see rather than it's converging views with maybe 2 different approaches, which is quite good. So I don't see a serious contradiction. between the results.
Okay, thanks a lot. Thanks a lot, Lucius. Ulrich or Nikolaos, is there something you would like to add from the perspective of Organic Plus?
Yes, yeah, I agree with Lucius. I think there are similar methods. Maybe the one thing we could say that what Lucius said earlier, the interviews we did was in 2016. So basically before, when 6 kilograms were still allowed, and as Lucius pointed out, that has gone down to 4 kilos. What I was interested in the RELACS data was more the total amount of copper used, and also I would want to know it in relation to what is used in conventional crops. I mean, you showed very well, you know, the biggest crop is olive, then it was grapes, and then almonds. I think that's really interesting in a way to focus it. But also, do you know, or does anyone know, how much is used in conventional olives and conventional grapes? And do we know the ratio between organic, of the total copper use on organic and conventional? We need good data for that as well, so Lucius. So that's back to you, Lucius. Yeah.
Okay. But there are market survey data which are really expensive and which may be true or not. We have quite, I think in Germany and in Switzerland, we have quite solid overview of what's going on. So what we found is that conventional and organic farmers use copper in similar proportions. So if you have, say, a 15% of 10 or 15% of organic surface, you would find about 10 or 15%, or maybe slightly higher, but not much, of the copper consumption. So it's really linked to it. What we also observe is that it seems that the copper use declined over the past year overall, over the past years, but it seems to stabilize because there are new, in conventional farmers, there are new uses like in sugar beet, where copper has been improved. So now it's increasing again. And what we also see is that, for instance, in grape wine, they use the copper often in combination because it's inexpensive, and it's also a tool to prevent resistance, well, build-up of resistant disease pathogen populations. So I would speculate that the larger the area of organic farms grows at the moment, then it would just be proportional to the overall use, unless we come in with the strategies, the combined strategies, and the all methods to reduce the use.
And do you think the same applies to olives and grapevine then? These are two crops that are not really grown, or grown to a lesser extent in Germany and Switzerland?
No, grapevine is popular.
Yes, of course, so, yes, but not olives.
In both areas, olives and nuts came as a surprise to us. In our survey, we didn't narrow down on purpose. We included all crops that are grown in order to find surprises, if you like. So what we saw in Italy and then Switzerland and so forth, but also Germany, was what we expected in the sense that grapevine is important and apples are important and potato are important and so forth. But the relative importance of olives and of nuts came a bit as a surprise. And we didn't find much information out there on those crops anyway.
Okay, good.
The only thing I can add to olives is that it's mainly due to the olive fruit fly, and because it's the only one that you can use in conventional and organic agriculture, but it depends on the lack of monitoring that normally you have among these kind of past, because one time it was easy to find even data about that, but now it's quite difficult because the lack of monitoring is common, at least in the southern part of Italy, where there is a lot of olive trees. And unfortunately, there is even a low level of predictability of the presence of the olive fruit fly. At the same time, but one of my colleagues said it before, copper is not only used as a chemical pesticide, PPP, but there are only other kind of use of copper, like fertilizer and other kind of products, in which becomes quite difficult to find real information about that.
So in the case of olive, the copper is used as an insecticide and not as a fungicide.
Yeah.
Okay.
Even
good.
This.
Then a question for Annegret. You mentioned in your presentation that the efficacy of the products that you tested as it's a potential for reduction of coppers is between 10 and 50%. Could you elaborate a bit more according to crop? So what would it be for apple? What would it be for vineyards?
So like I showed, starting maybe with the greenhouses, I think that there we have more, as I showed in my slides, we used it as a standalone treatment, and we got very good results and sometimes as effective as copper. And so I think here we have a very high potential to reduce the amounts of copper. When we go to the field situation, then we have really the situation, it depends on how is the weather. So this year, for example, we had very extreme weather situation, very high disease pressure, a lot of rain. And so this in grape and in apple, it will really depend on where we are, what is the climate in that year. So this is why we had this 10 to 50% variation. For sure, in the greenhouses, there is a high potential in the field as well, but this will depend on the weather situation. And in apple, for example, we already have, for the curative treatments, we have a number of substances that are applied already. And so it will depend on where we are and how the climate further develops. So it's not so easy to say in that crop we will have such percentage and in the other crop such percentage.
Okay, good. Then another question for you is coming from Soraya Francia. She asked about the impact of the products you studied on biodiversity and in particular on natural enemies. Do you investigate that?
Mm-hmm. I mean, when we started out with RELACS, as I mentioned, we already had other projects before. And in the other projects, we looked into the side effects on beneficial organisms, a variety of beneficial organisms for some of our products. And what we found there is that there were no effects on the investigated, on terrestrial organisms, on aquatic beneficials. And what we did in RELACS, that we also in some of the trials looked into the effects, for example, on phytoncide mites in grape, where they were also investigated. And we found that compared to the copper treatment, there were no differences between effects. There were no significant effects on the phytoncide mites in these trials. And so maybe Lucius, you also want to add something to this. And like I said, for the tagatose, this is already generally regarded as safe substance. So we also have some more information on a broader base here.
Lucius, do you have something to add there?
Yeah, just to add, the full details are available when the full dossier is prepared. But of course, the products are in different stages of development, but none of it received a red flag in any case, because then it would have been the development would have been discontinued. So if there is an alternative which is really good but shows negative results unexpectedly when preparing the registration dossiers, then it will not not be approved. But it looks good. We have seen no red flags so far.
Okay, good. Thanks a lot for this addition, Lucius. Then I have two questions for Nikolaos about the products studied in Organic Plus. It are two quite technical questions, so I don't know if you will be able to answer, but let's see. So Anne-Christine asks if this gluconic product that you mentioned and has such a good efficacy, do you know a mechanism, an explanation why this was such a good working product?
And unfortunately, Bram, I have not the reply to this question. I missed this information from my colleague Miguel de Cara from Spain, and so I'm sorry I cannot give it.
Okay, good, no problem. Then I will move to some questions about vibrations. It's a question from Bas Drucker. Also, there is a question about the impact on the natural enemies. So Vincenzo, can you explain this for the audience?
No, we are doing, of course, this is depends on the beneficials, depends on the place in which they are working, the place we did some trial in lab and nothing happened to the beneficials using vibrations in a cage before in semi-field conditions, more or less a small greenhouse. And we are monitoring even after launching them in our field. No effects on beneficial. Why? Because the mating disruption signal that is made using the vibration is something that has been measured before. So if we know the pest, we measure what is the vibration frequency that we have to put in the tremors, and they are disturbing only that kind of pest, not even the other kind of pest, because any insects or rather any pest has got a personal frequency. I don't want to get into too much detail because it's quite complicated. It's more acoustic than entomology, but this is the story. Normally, we are using even beneficials in open fields, no problems in the predating or parasitoid activities.
Okay.
At the moment.
That's very good news. Then I'll turn back to Nikolaos. You presented a new decision support system that you developed. I was wondering if other decision support systems already exist that do similar things, and what is then the difference between your decision support system and what is already available, if something is already available?
Yes, there are available decision support systems, but they are mainly focusing on open field, not mainly for greenhouse crops. And the novelty, the difference of these decision support system is that it predicts the infection. It does not just model the infection that we may have based on the conditions that have in the past, but it predicts the possible infection in the future based on prediction of the weather in the region that the greenhouse is located, and based on the characteristics of the greenhouse and of the management strategy of the greenhouse. So this is a new thing that we add in this puzzle.
Okay, good. Tomorrow we will discuss how some of these findings can be turned into reality, what actions are needed for that. But I see there are already some questions in the chat coming to related to this subject. One is from Jutta Kinsler, who asks about a specific product, the Neudorf product, but we've also learned about other alternatives today. So Annegret, if you in the remaining minutes can elaborate, or Lucius, whoever feels like answering, what steps would be needed as a kind of anticipation of the discussion of tomorrow?
Lucius, do you want, or?
I can,
Yes.
if you like.
Yeah.
in the context of the alternative products, we see a few bottlenecks. One is that the costs for the registration and the market size is for the industry often a bit of a limiting factor, and especially the timeline between submission of a dossier, the cost for the dossier, submission of the dossiers, and the timeline until approval is limiting. And then it may also be limiting that the costs of treatments per hectare, for instance, are much higher than the dirt cheap copper in this case. That's a major restriction. So what's actually needed probably, and I will address this tomorrow, but what's actually needed is a full package of support activities, which at the same time allow for an accelerated approval process, but also give some security to industries that their product will have a place in the market of the future. So there must be a range of different instruments, and of course they have to be synchronized in a meaningful way. Else, I can't see that the transition works as quickly as we would, and as smoothly as we would wish for. And we can. What's pretty clear is that we can't leave the industry just alone. It's not such that the market will regulate everything. So we need these supportive activities.
Okay, good. I think that's very clear. Without concerted action and without policy support, we will not reach our goals. We cannot leave it to the market. Vincenzo, you also mentioned for your vibrational device that support is needed here. The issue is not registration, I suppose, but it's more knowledge and investment support. Would you like to elaborate more on what kind of support would be needed to implement?
The support is, first of all, a training of the farmer. This because to be quite clear and to be even practical, cable should touch the crop. Otherwise, the vibration will not perceive it from the crop and, of course, from the leaves when normally the pest lands. This seems stupid, but this is the first one. Secondly, according to the dimension of the orchard, according to the size of the crop, according to the age of the crop, not variety, more age, you have to define or which extent the vibration works. So it's not easy to calculate. We have, for instance, less number of devices for the vineyards and more number of devices for olive orchards. And according to the age of the crop, we are going even to move the tremors once the crop will grow. You have seen that there are young trees of citrus, what I'm working now. Once they will grow up, we have to change the place in which the tremors is placed. So it's not complicated. You need to be careful, but you need a training course before installing, and even someone that can help or monitoring the checking how if the system works. If the system falls down for different or stupid things, such as the battery doesn't work, or there is some problem in the cables, this is something you have to solve quickly.
Okay, good. Thanks a lot for this. I will finish with one more policy-related question. We know that the farm-to-fork strategy has set very high objectives to reduce the use of pesticides. So there is high pressure also in the conventional sector to reduce pesticide use. And do you think that the results that that Organic Plus and RELACS have come up with can also help to reduce pesticides in the conventional sector? It's an open question to all of you, whoever feels like answering.
Well, I think that, of course, any alternative that is applicable in organic farming can also be used in conventional, in integrated farming. And also for the companies, that are behind the products, for them, it's also very important to have a broader market, because then, of course, it's more feasible to bring them to registration and to bring them to the market. And of course, anything, the decision support systems and alternatives, and a measure can be also used in conventional or integrated farming.
Okay, good. That's good news. Lucius?
Yes, all is true. However, I would speculate that the alternatives and also biocontrol treatments and so forth, they fit better into stabilized agricultural systems where the preventive strategies have been fully exploited before even starting. So if in a system where we would use robust varieties and soil fertility management and so forth, they fit. Our alternatives would probably give the best results as compared to if you use it in a monoculture, you know, really depleted system. But there is spillover, that's quite clear, and as Anne said, the industry speculates on that. They don't target on the organic market alone.
So in conclusion, preventive measures still come first, and managing your ecosystem and get a stabilized agro-ecosystem is much more important than having your inputs right, and then inputs come at a second step, and then if your system works well, the inputs can do their work as well as a second step. Ulrich?
Yes, I just wanted to go to one other aspect is terms of regulation. You know, we said the copper regulation, the 4 kilos obviously apply not only for organic, they apply for conventional. And it came in some way from the whole conventional discussion. And we'll have that a little bit later with Pete as well. So the question I have, for example, if mineral oils are a thing which is a fossil fuel and a bad thing, wouldn't it be better to phase it out also in conventional farming? And then the alternatives, the farmers who develop alternatives, Vincenzo, yes, especially you, would then have an easier and bigger market for the orange oils and the other things. Yeah. And then the additional question, should we team up with conventional sector to phase out mineral oils?
Yeah, I'm afraid we are opening now a new big debate. It's an excellent question for a coffee table, actually, and it is also time for a break now. So as my colleague Laura has explained in the chat, we have now a break, and you will find coffee break tables where you can have an informal exchange of what we have discussed now, or also other subjects if you like. And the speakers of this session will also be available. So if you have would like to speak directly with some of the speakers, I invite you all to join these coffee tables. And we will continue in the main session at 11:20 to speak about soil and nutrients. So I hope you've enjoyed this first session, and I see you back at 11:20.
Thank you.